Good morning, and I'm Amy Benyon. I'd like to tell you about Chromatrap, who we are and what we do. So Chromatrap is a brand of a company called Porvair Filtration, and Porvair are filtration specialists. We have operations in the UK, US, Germany and China, and our main commercial revenue is in filters in airspace and aircraft. However, we also specialise in gas, metal and ceramic filtration. We have very attractive business characteristics because we have bespoke products and assays, but also process reliability, and we hold all the patents and design rights of our filters. So Chromatrap use the expertise of Porvair Filtration and their filters for manufacture, production and quality control, and some small-scale R&D. Porvair Sciences, who help us with all our marketing and distribution, and also a collaboration with Swansea University, looking at and responsible for the majority of the research and development and the technical product support. So the question is, what is Chromatrap? So I said we use the expertise of Porvair Filtration, and in particular their sintered porous high-density polyethylene with a trade name of BioVion. And what we're trying to do is apply BioVion in bioscience applications. So with BioVion, we can manipulate the pore size, but we can also chemically modify the surface. And this provides us with a large, inert, porous structure suitable for the capture of biological material. What I'm here to convince you of today is that we think that BioVion is the perfect substitute for magnetic anhydrous beads due to its significant advantages over beads in handling quality, accuracy, and it allows the capability of high throughput. So our first venture into the bioscience market was in epigenetics. So you've seen some excellent talks over the last 2 days on epigenetics, and briefly, it's the study of the organisation of the genome, and in particular refers to a set of heritable changes in gene expression. These changes are known to be caused by external factors such as the environment, and refers to the set of changes themselves, so histone methylation, DNA methylation, acetylation. These obviously affect the availability of genes to be activated and ultimately affect gene expression. This can affect health outcomes, but what's really interesting and important about these epigenetic marks is that they are reversible and therefore a great therapeutic target. So in certain disease states such as cancer, you get a change in methylation status, and we want to target these changes with certain inhibitors or drug targets to reverse and help in disease states. So the way to look at these masks is a method called chromatin immunoprecipitation chip. And this is routinely done in the lab with magnetic anhydrous beads to immunoprecipitate. But anyone who does chip, it takes a long time, it's quite complex. And there's a couple of challenges that beads haven't overcome yet, especially small size samples. So that's where Chromatrap came in. So we provide an alternative scaffold in the form of BioVion, so an inert solid phase filter for a better immunoprecipitation. Because it's in a solid state, it can be put into a spin column, and this provides ease of use. The fact that it's inert means that we reduce the non-specific binding often associated with beads, and the porous nature of the material means it promotes molecular mixing within the sample, and you don't have any sample loss. So this is the technology, and what I'd like to show you is our advantages and why we think we are better than beads. So I mentioned the much faster, simpler process. We can go from chromatin prep to downstream analysis in under 5 hours. There's less manual handling, so you get a much greater reproducibility. And the fact that it's in a 96-well plate also aligns itself with automation to further speed up the process. We always achieve a robust signal to noise when looking at antibody enrichment over background, and we're designed for small sample sizes, in particular from difficult samples such as biopsies. And because we routinely load just 1 microgram per IP, means that you can get more samples per assay, look at more targets. Alongside our high and low cell numbers suitability, it makes us an ideal platform for chip seek as a downstream process We've validated this on both transcription factors and epigenetic marks, but what's really important is that you get enough DNA from one single IP to do your library preparation, which isn't always possible with beads. A lot of time you have to pool multiple samples, and we're fully compatible with all the major sequencing platforms, including the MiSeq and the HiSeq. So I mentioned that we have a high throughput 96-well plate, and I just want to highlight the flexibility of this assay. Because of our lower chromatin loadings, it means that you can look at multiple antibody and gene targets from your one sample. This gives you a much better investigation of widespread effects. It also reduces any ambiguity over sample preps. You can run all your clinical samples, all your cell lines, all at the same time and in just one day. So it allows the first time up to 96 IPs. On the right hand side is just an example of a plate layout where we've done multiple antibodies, multiple cell types, and I'm just going to briefly show you the data. I'm not going to go into too much detail, but you can come and see me later to discuss, but it's just to highlight the flexibility of Chromatrap that we have here. 4 different cell types, 4 different antibody targets, and 5 target gene loci looked at. However, I want to emphasize that this is just from 2 columns of that plate. The amount of data you can get from the 96-well is pretty impressive. I keep going on about the number of samples you can do per assay, and this data is quite nice as it shows that you can look at your transcription factor marks, but then you can also run alongside your histone modification marks to gauge more about the epigenetic landscape and the state of your chromatin. So at the top here we have RNA pol, transcription factor associated with open chromatin on GAPDH, and we run from the same sample your trimethylation on lysine 4, histone 3 associated with open chromatin, and also our trimethylation on lysine 27 of histone 3. And we have an enrichment alongside RNA pol, as you would expect, and then no HCK27. It's just, again, further data to show how selective and sensitive our assay can be. So to take you back to the beginning, I mentioned that the chip assays were routinely done with magnetic and agarose beads, but now hopefully I've convinced you that BioVion can come and replace these assays. We're hoping that we will be able to bridge the gap between fundamental epigenetics research and looking in vitro models, but then bridge the gap towards clinical epigenetics by providing a sensitive, selective, reproducible assay. The fact that we can do high throughput screening means that we can help companies not only look at disease biomarkers, but hopefully lead the way towards therapeutics and combine it with drug discovery companion diagnostics. So hopefully I've given you a brief overview of Chromatrap. This is where we are based in Swansea University, and hopefully as well showing you the advantages of BioVion in chip assays, as that's where we started out. But you can see, because of the manipulation of the pore sizes and the chemistry, that we can apply it to a lot of other applications, including protein, DNA and RNA. I'm on stand number 18, just around the corner, if you want to come and see me to discuss any of the data shown here or our future project developments. Thank you.